bar, we take n equal 3, we take n equal 6, we take n equal 9. When we increasing the value of n, we improve our solution till we at phi n equal 9, we reach to exact solution and error equal 0 as shown in this table. Error equal 0 when we take n equal 9 in our solution. The second example, we take the kernel sine x plus x square minus cosine x plus 1 plus 2x. In table number 2, we take n equal 6, 3, 9, and we reach to error equal 0. Our figure U1, U2, U3, we improve the solution until we reach to exact solution. Conclusion, the complexity of solutions is remarkably reduced, the time is saved, and round of error is minimized. The numerical solution near the end points are equal to the functional value of exact solution when applying pericentric Lagrange interpolation via Van der Waals matrix. Thank you. Any question? Any question?
Thank you for your presentation. Any questions? You have 3 minutes for questions.
Okay.
Any questions for this presentation? Okay, no worries. I think, Basil, we can move on to the next one.
Yes, okay. The next presenter is Munir Awad, presenting impact of database configuration on process control systems, performances, and lifetime. Case study of a distributed control system in the oil and gas industry. The floor is yours. You have 12 minutes to present.
Okay. Good morning or good afternoon for others. Let me share my presentation. Okay. Can you see my presentation?
Yes, it is clear, yeah.
Okay, thank you. Okay, my name is Munir Awad. I am assistant professor in the University of Rotterdam. So I'm pleased today to present my paper entitled Impact of Database Configuration on Process Control System Performances and Lifetime. As a case study, we have taken distributed control systems in oil and gas industry. So we follow the presentation plan for this presentation. PCS is a general limit that surrounds several types of control systems or PCS control systems. So a process control system, commonly called PCS, often found in the industrial sector and critical infrastructure. They are typically used in heavy industries such as oil and gas, electrical waste, water and wastewater, chemical, and others. The main functions of a PCS system are to ensure the monitoring and control of an industrial process. So among these control systems, we can find the SCADA systems, or supervisory control and data acquisition. When industrial process is spread other large distances like oil field wells, electricity distribution, and others. DCS, or distributed control system, when regulations requirements are relatively stringent, and other more small control systems, which we call PLCs or programmable logic controllers, often found in industrial sector and critical infrastructure. Therefore, to ensure an effective role of all these systems to achieve their reliability, availability, maintainability, and stability, this requires optimum hardware and software configurations. Indeed, among these restrictions, we find database memory saturation, which causes significant system performance decrease. So the question to answer is how to enhance performances and extend lifetime of control system. The proposed answer is to optimize system database configuration. So let's see now what is a DCS, or distributed control system. A DCS is a combination of single local control concept and computer networks. The distributed control systems have greatly improved the management of industrial processes with more flexibility and security. They allowed centralized management and supervision with distributed control. Typical architecture of a DCS includes three main levels. The field information level, where we found field instrument; control process level, where we found several network connected controllers to ensure regulation function; and finally the supervision level, where we found several client servers. Each server has a different interface according to its mission. The most common servers we can find are communication with the input-output devices, monitoring, and others. So we can find on the top of the architecture an upper level corresponding to computer management of all acquired process data. Typical software found here is the ERP, or enterprise resource planning. So as a case study, we have taken DCS of an oil field, Bir Ba'nor, in the Sahara Desert of Algeria. So its main characteristic is that it belongs to a hardware and software family, which can be integrated selectively in content data acquisition system that corresponds or responds to quite specific needs. Its main components are, a main communication network called LCN, or local control network, one or several network UCN, universal control network, and an HPM, or high performance process manager. It's similar to a PLC. It allows scheduling a large choice of control functions and data entry. It is the interface between the DCS and the input-output instruments related to the process. So the HPM controller performance measurement are divided in two main categories. First one is the MU, or memory units. Memory unit performance evaluates the memory units in terms of memory capacity. For each HPM controller, it is possible to configure a maximum of 22,000 MUs. The number of configured MU depends on the number of each configured control function, as well as numeric values, number, and sequence program blocks. Second performance measurement is the PUs, or processing units. In terms of data processing units, memory units are also called, the PUs are the data processing units. The number of configured PU depends on the number of and scan rate of each configured control block or function. Let's see now how we perform, or how we deal with the memory saturation analysis of this system. What are first the memory saturation causes? After this case study done on this DCS, we have made an in-depth study on this system, and then we have identified main important problems that are affecting its operation performance. The most important problem that is affecting control system performances and the overall process operation is the problem of memory saturation. From the HPM controllers of the SADIAT control, 3 kinds of saturation were identified. The first one is the logic memory saturation, which is due to bad database configuration. For example, 125 digital composite slots, but the system uses only 35 points. So 90 points are allocated from the memory, but not usable by the controller. This case is repeated over all system controllers. The second cause is some points, like Allen points, need only a bit, but is reported on a byte. A bit needs only a flag, but it is declared as a digital composite on the system. And the last cause of memory saturation is that system uses points for a temporary work, but the memory logical location of these points remain unexploited despite they are no longer physically used. So we can see here on this engineering station, we can see for this sample controller, almost all the PUs or the processing units are used, and more than 86% of the memory is consumed. What are the effects of memory saturation on the system? System does not allow new input-outputs extensions because controllers say displayed on system indicates that is saturated, but on physical rack, we still have spare slots for new input-output modules. There is no operation of the controller. The data processing time is impacted with which affects control processor performances. And finally, time refresh of acquired process parameters is affected. So let's see what are possible memory saturation solutions. So on this table, we have summarized possible solutions for the memory saturation. From this table, we can say that existing system upgrade is the most advantageous comparing to revamping solutions. But facing to operation and production stability, the solution of memory saturation cannot be delayed. So we believe that the database reconfiguration as a temporary solution constitutes the best timely solution at the moment. It will allow management, database reconfiguration of input-outputs points connected to the controllers, avoid memory saturation that control system is suffering, and finally, extend control system lifetime before resorting to upgrade or revamping solutions. Execution steps for the database reconfiguration are, first of all, we had to calculate possible profitable memory space, MUs, and capacity of processing PUs for each configurable point, calculate possible beneficial memory space and the capacity of processing for each controller, which is the total of all profitable memory space. And finally, we had to configure the system according to the results found in step A and B, where we must respect the configuration strategy based on 70% used memory units and 30% free to avoid the saturation of the PUs, the total size of the control memory, which is 22,000 MUs, and the processor control capacity, which is 800 PUs. Okay, we can see on this screenshot that the effective for this kind of data, effective from among 140 PUs, effective used MUs are 299. So we can have a profitability of more than 1,300 MUs. The same for the PUs, for the MUs. Among 1,625 available MUs, only 299 effectively consumed, and we can make profitability of more than 1,326 MUs. So the overall gain profitability will be for this controller more than 1,000 MUs memory units and almost 600. We can see also on this table, after database reconfiguration of this controller, we can see the table. The total load has decreased from 86% to 70% for MUs, and from 99% to 54% for the PUs. As conclusion, we can say that process control systems use decentralized architecture to control manufacturing processes. The architecture involves hardware and software components, from the central control panel to the remote controllers and input-output modules throughout communication supports. To obtain optimal operation of control system and take advantage of its features, it is important that the initial configuration of the system is made on correct practices. The most important problem discussed in this paper is system memory saturation, which significantly contributes to performances decreases. Saturation of the system is the effect of inadequate database configuration during the engineering phase of system installation project. So due to time and production continuity constraints, we proposed a system database reconfiguration as a solution for the memory saturation, which represents an optimized time and cost solution. But this solution fits into an upgrade maintenance, which has an objective only to increase system lifetime and then prepare to a smooth system upgrade or revamping. Thank you for your attention.
Thank you for your presentation. Now we are open for questions. You have 3 minutes for questions. Any questions from the audience?
I have a small question for the presenter. You talked in your slides about how to avoid the memory problems by configuration of the database, and also you have explained the provision mechanism to improve the process control configuration.
Yes.
This is good, okay. When we control a manufacturing process, which is in real time. Can you tell me if your approach, in the slide, I have not heard about response time of the systems, in the sense that your concern was on memory saturation, etc. But are there any guarantee that from a given event in the industrial process, from a given event to its response, is there any guarantee in the response time of the system?
Okay, you are talking about the time of response of the system in case of an event.
In case of an event, because we manage a process, industrial process. And
real time, yeah, it's a real time process. Yeah, yes. You are asking if this event will affect the performances of the system or reconfiguration.
I would understand if configuration, process control performance you carried out can guarantee a response time to the event?
Okay, at this, if we, if we,
not on the average, we need absolute guarantee that we react to the event with a given time window.
okay, the system as it is in situation of saturation. So we cannot add new input outputs or make an extension of the process. So what we have made is to make a reconfiguration. So the state of the system as it is now, it is too slow. So I agree with you. If in case of an event, maybe it will be a problem to detect this event. But if we made a reconfiguration, so the system will be more comfortable, if I can say, and I think as a process system, it's important and it's imperative that it should detect any events or alarm in the time.
Yes, yes.
Because these kind of systems are real-time functioning. So the refresh time or is about seconds. So I think in normal functioning or normal operation, the system should detect any events. Yes.
Okay.
Okay, is there any more questions? Okay, then we'll move to our next presenter. Our next presenter is Janat Binta Alam, presenting machine learning approach for predicting COVID-19 suspect using non-contact vital signs monitoring system by RGB camera. The floor is yours. You have 12 minutes to present.
Okay, hello. Hello, can you hear me?
Yes, we can.
Okay, thank you. Okay, I'm sharing my screen. Okay.
Yes, it is visible now.
Okay, thank you. Hello, I am Janat Binti Alum from ICICT Group Limited. I'm working as a programmer currently. Okay, so my paper title is Machine Learning Approach for Predicting COVID-19 Suspects Using Non-Contact Vital Signs Monitoring System by RGB camera. We all know about the COVID-19 and its impact during last year. Okay, so I'm moving to next. Okay, first overview. I'm going to present first overall objective, then a short introduction of our study, then the methodology we have used through the study, and after that the result we have found for this study. Next, the conclusion, and finally I have included the references I have used in my paper. So our main objectives of this study are to predict COVID-19 suspect among the suspected and not suspected individuals, which are we all know the or every sector and every individuals we are uh, we are remaining in this world uh, hmm, are in shock of COVID-19 because it's having great impact in our lives, daily lives, and we are really surviving a disaster, kind of disastrous life anyway. And so our main purpose of this study is to predict the COVID-19 suspect. Then as we want to predict COVID-19 suspects, we have tried to find out the major non-contact vital signs to predict those suspects. After that, we have also not only find out the major non-contact vital signs, rather we have developed and designed a predictive model using machine learning approaches. And through this development, we have implemented RPPG algorithm to ensure the non-contact vital signs monitoring system. Okay. Introduction. In this current scenario or in this current world, in this current time, we are really having a difficult time, truly the difficult time, and the world is facing really difficult time. Starting from the very normal people, even though the health workers, the doctors, the patients, everybody are facing the difficulties and and the affectedness for this COVID-19 virus. Already many we all aware on that. Already we have many dead bodies due to this COVID virus. Health workers and the doctors have already died due to this COVID. So we are coming to point to check the vital signs for taking precautions for the individuals who are keeping them safe from this COVID-19 virus. So as we know already, new variants have been introduced, and those are SARS-CoV-2 B117 and SARS-CoV-2. It's saying variant 521 V2, which are due to these two variants, number of patients have been increased very dramatically. So this has been very tremendous and very much painful for our lives. To take early precautions, a person needs to check his vital signs regularly, because sometimes COVID-19 does not show any symptoms, and that's why the existence of the disease remains unknown. In fact, sometimes it's being crucial to check blood oxygen saturation to detect silent hypoxia. Silent hypoxia occurs without shortness of breathing, and in this case, it may lead to COVID-19. On the other hand, we have seen some new variants. What I have already mentioned. This is the reason for the spreadness of this virus. So we are focusing to predict something which can ensure a regular checkup without direct attendance of health worker or doctors, or can be nurse, or can be anybody. We wanted to ensure everybody's precautions remotely, so that everybody can ensure uh, they are to check they are whether they are already impacted or not, they are affected or not, whether in fact if anybody is already in uh, quarantine, already affected, they can obviously they are in quarantine, so they also require the regular monitoring. So we need something which can predict whether he is improving or not. So that's why we have introduced this study to check and to help in general. Anyway, so uh, going through the next slide, experiment setup. For this experiment, we have used a very personal or default webcam for the laptop. We have been used. So I have mentioned the laptop Lenovo IdeaPad 320. With the RGB camera of this laptop, uh, we can check the check the capture. We can take the capture and then step by step processing, and after processing we have come to a result to give it as output to the user. For commercial checkup, which is to check the accuracy of the study, we have used contact pulse oximeter, which uh, which has the accuracy level customized to 2%. And for making the user interface, we have used PyQt4. Let's move into methodology. Mainly we have been used RPPG algorithm, and in fact we have been implemented this algorithm to predict the suspect and find out the non-contact vital monitoring system, non-contact vital signs. So in RPPG algorithm, we have five steps, which are the frameworks for RPPG algorithm, uh, which is which is called as remote photoplethysmography. Uh, in this algorithm, firstly we have to ensure first 5 steps, can say. It is known that the blood periodically moves from heart to head, and the process happens in every cardiac cycle. When blood flows through the arteries, absorption and light reflection take place. The process of light reflection and absorption are observable by computer. So we have firstly taken few frames, with a resolution of 480 by 660 pixels. Initially, 10 seconds are needed for camera distortion and fixation, and then frames are successfully grabbed from I/O, and then behind of that, a multi-threading process has been implemented for I/O. Here we have been used OpenCV package for Python to process the frame. In fact, using this camera, but I have already said the default camera that we have used, and to take the frame, we have emphasized on the frontal face rather than the forehead. We all know that the the cheeks and the forehead are considered to take very accurate frames, but we have been emphasized on cheeks as sometimes the forehead can be covered with hair or can be cloth. So we have considered here uh, cheeks. Um, Dictate landmarks in face have been detected and acquired from facial landmark detection algorithm. Um, and from frontal face detector, DLib library has been used to detect the face to get the desired frame. Um, as I said, ROI, that is the region of interest detection, uh, is important task here. Uh, Usually all portions of the face not contains exact and precise clinical information. That's why three ROIs are detected from the detected face. Two ROIs are used for two cheeks, and third one is for nose region. In this research, also we have good features to track algorithm, uh, which has been used to extract the tracking points. After that, Carnegie Lucas Thomas D, which is shortly said KLT algorithm, is implemented to track the extracted points depending on subject motion.
Sorry to
Next,
interrupt you, but you still have 2 minutes.
2 minutes, right? Okay. Okay. Uh, After that, we have done raw signal extraction, uh, uh, and then we have estimated the heart rate, respiratory rate, and oxygen saturation as saturation. Um, and finally, we have estimated blood oxygen saturation to get the users non-vital symptoms, symptoms which have been calculated by this RPPG algorithm, and then we have came up to machine learning approaches to train the data set, and we have been used the CEO Lebanese Hospital Brazil, one of the hospital, which data we have found in Kaggle. We have been used that to train and predict. Finally, came to a result. So to use to train the data set, we have been used support vector machine, neural network, and logistic regression. Finally, we have coming to results, and in results we have found the most precision 0.98 for non-suspect class, and throughout the SBM, and same for 9A recall F1 score and support. We have been calculated precision recall F1 score and support to compare these three algorithms, and to check our accuracy also. So in accuracy, we have found the most in using SBM, which is 97.91, almost near to 98%, and mean square error was 0.038, sorry. And finally, we have came to a point as the mean error, the absolute error of heart rate was 2.11 for 2%. One thing I have missed is we have real time. In real time, we have taken to 7 participants to test in real time, and we have found the absolute error of heart rate for them for two participants of them was 2.11 and less than 4.06 for other 5%, and the absolute error for oxygen saturation was 0.0 for 4 participants, and absolute error for 3% was less than 1 as the mean bias was 2 plus minus 2 for valid blood blood oxygen saturation. So as in generally in medical science, it is considered that 2.11 to 4.06 is can be varies. Sorry, I have mentioned 2.11 to 4.06. It was we have get this in this difference, and for heart rate mean bias can be vary from 2.08 to 8.06 in general. So that's why we have come to reach that we are in acceptable range, and the study is fulfilling the objective which I have already said, to predict the suspect and to help in general. This okay. Uh, so our priority was to ensure highest accuracy of this prediction system, and so that it can be used widely without direct attendance of uh, healthcare individual, and uh, uh, the lower in work cost, obviously, and mm, to help in general. So hopefully uh, we have done, and mm, yeah, that's why we are really feeling good. So thank you everyone. Thank you so much.
Thank you for your presentation. Is there any questions? You have 3 minutes for any questions. Okay.
Any questions from any of the participants? Okay, no worries.
Yes.
Basil, I think we can move on to the next presentation.
The next presenter is Michael Chernoskutov.
Is this the last
presenting.
presentation or we have one more?
Yeah, we have one more. Uriel
Okay.
A.
No worries.
Presenting using graphs for classification. The floor is yours. You have 12 minutes to present.
Hello. Let me share my screen.
Yes.
Do you see the presentation?
Yes, yes, we do.
Okay, let's begin. So my name is Mikhail Chernoskutov, and my today talk is about using graphs for classification. So classification is one of the main tasks in machine learning, and it is about predicting the labels of some examples from test set using just examples from a train set. So we learning on examples of train set and somehow make predictions about the examples from test set. I developed an algorithm which is use graph of nearest neighbors for classification. So it has the following features. It may be used both for binary classification it's a classification just between two classes, and multi-class classification. It's for situation where we have more than two classes. So my algorithm does not make any difference between these two types of classification. And also it has one important parameter. It is use any algorithms for community detection. So I'll talk a bit about community detection a bit later. And sorry, here is a step-by-step description of the developed algorithm. So in the start, we have the train and test sets in the form of, for instance, a data frame. So we have train set examples with features. Sorry, with some number of features per each sample. And we built the graph of n nearest neighbors from the elements of train and test sets. And yes, the graph is built both on elements on train and test set. So the all elements are located inside the one graph. And h weights is the distance between elements, is the Euclidean distance between elements with the power of -1. So the smaller the distance between elements in the train or test set, the more we have weight on H between these elements. The next step is linking nodes that are two hops apart from each other. So we have the following inequality with alpha coefficients. And if this inequality holds true, so we put additional edges in the graph. So this step is need just to, a bit densify graph and makes it a bit more connected. It help to detect the community in such graph in the next step. And the alpha coefficient is needed just to regulate the number of new edges. So we can add more new edges or we can add less new edges, and it can affect the quality of classification. So the next step, we detect the communities in the resulting graph. And one important detail is that the number of communities may be much more than the number of classes. So we may have the task of binary classification. It's just two classes, and we have, for instance, 12 or 20 communities. So that has happened because the elements forming, some subclasses inside the general classes. And step 4, we marking the nodes belonging to a train test and test set. So for instance, in this example, we have two classes, 4 elements of train set. For instance, green and and red. And we mark in this node in each communities. And the gray node is elements of test set. So the class of these elements we have to predict by learning on the elements of train set. And you see that each community may contain elements of different classes, but we are looking just to most frequently occurring elements. For instance, in the left community, we have more green elements than red elements. So we are marking the previously gray element as green. And for instance, in the community in the right, we mark gray element as red element. And this way we are making the classification of the elements of test set. and benchmarking. I take two datasets from scikit-learn library. First is breast cancer, which have 569 elements and 30 features per each element. And handwritten digits, it is multi-class classification with 10 classes. So 10 classes is just the digits from 0 to 9. And it has almost 1,800 elements and 64 features per each element. And I choose the performance metric is part of correctly classified samples in the test set. And I choose a standard ratio between train and test set sizes. This is 80% of elements fall in the train set and 12% of elements fell in the test set. And I choose asynchronous label propagation community detection because it can deal with weighted graphs. So here is the results. Firstly, for breast cancer data set, you see in the column different values of alpha coefficient and the number of nearest neighbors. I test two types of nearest neighbors graph. Firstly, with a couple of nearest neighbors, and the second is with 3 nearest neighbors per each data element. And in the third column, you see the number of edges in the resulting graph. So you can notice that it is different in almost all experiments, and the number of communities. So I noticed earlier, the breast cancer dataset is a binary classification problem, but here we see that the number of communities in the resulting nearest neighbor graph is much more than 2. For instance, 84, 140, 52, or something like this. And we have a score which is a part of correctly classified samples, is the best result is 0.947. So it approximately 95% of elements are classified correctly in the test set. And the result for handwritten digits, here is a bit better result, and here is almost 99% of all elements in the test set was classified correctly. And the baseline for our benchmarking is random forest from scikit-learn and XGBoost. It's a very famous gradient boosting algorithm for classification. And you can see that for breast cancer dataset, both random forest and XGBoost perform a bit better. So here you see 95, 96% of correctly classified elements, and I have 94 and 95 approximately. But for a handwritten digits dataset, random forest and XGBoost was underperform my algorithm. Here is 95, 96% of correctly classified elements in the test set, but I have almost 99. So it's a rather good result for such well-developed problems. And the conclusion and discussion. So the main problem of my algorithm is that building of nearest neighbors graph is very time-consuming procedure. So I try to use heuristics, spatial hash, and other stuff like this to reduce the time. And also there is a problem of overlapping and non-overlapping communities inside the nearest neighbors graph. So we need to know what to do with samples that fall in more than one community. Also, my algorithm has some advantages. Firstly, it's interpretability of result. We see what community our element belongs to and why it belongs to. And my algorithm, the next advantage is use just a few of parameters. For instance, in comparison with XGBoost, where we have to specify many parameters. And also the last advantage, but it needs additional research, we may reduce the size of train set, because we just need to see what type of elements most frequently occurs in each community. But still, this need additional research, so I don't present it yet. So that's all. Thank you for your attention, and please ask questions. Don't hesitate. Thanks.
Thank you for your presentation. You have 3 minutes for any questions from the audience.
Okay, I may turn off the demonstration.
Any questions from the audience? Okay. I think, Basil, we can move for the last presentation. And thank you for presenting the paper.
The last presenter is... Sorry?
Hello. Yeah, I'm going to share my screen.
Yes.
Okay, yes. Uriel A. Pinson. You have, the floor is yours. You have 12 minutes to present.
Hello everybody. I welcome you to the paper presentation titled Self-Calibrated Redux System for Capacitive Biosensors. The authors of this work are Guillermo Espinosa and Uriel Melo, who's talking to you. I'm a PhD student at National Institute of Astrophysics, Optics, and Electronics of Mexico. A general biosensor readout system is shown in Figure 1, in which a biointerface interacts with an analyte, like a bacteria or virus, and it changes an electrical property like the capacitance. The variation is converted to an electrical signal by a transconduction stage, and, and then is amplified for signal conditioning and processing. For an E. coli biosensor, the capacitance versus bacteria concentration is shown in Figure 2. The sensor becomes more sensitive for bacteria concentrations about 10,000 colony forming units per milliliter, and the variations can be categorized in infection risk levels as shown in Table 1. One problem associated with related works about readout systems is the use of an external reference capacitor, which diminish the relative precision of the capacitance to voltage conversion due to biosensor manufacturing process. The proposed readout system is shown in Figure 3. To the system inputs a capacitance variations and outputs a digital word. The system is composed of a switch capacitor integrator, a serial comparator, a logic control unit, and an up-down counter. The system has 3 operation phases: a calibration phase, an idle phase, and a measurement phase. In the calibration phase, the sensor capacitance is charged to a specific voltage, while a counter in downward mode records the calibration duration. Then, in the idle phase, the sensor interacts interact with the analyte, which decreases the sensor capacitance. And finally, in the measurement phase, the modified sensor capacitance is discharged and the counter works outward. The zero comparator detects an integrated output voltage of 0 and stops the counter, which last value corresponds to the capacitance to digital conversion. This system is suitable when conversion time is not the main target, and a low power consumption and robustness again process and temperature variations are desirable. And figure 5 shows the switch capacitor integrator, which was modified from reference 1 by adding the measurement and calibration phases through additional switches and logic circuits. The integrator can work in inverting or non-inverting configurations by exchanging the known overlapping phases, phase 1 and phase 2, in the two input switches, this and this. In measurement phase, the maximum integrator output voltage is given by the product of a fixed number of clock cycles, the reference voltage, and the nominal integrator gain. In measurement phase, the sensor capacitance is discharged in steps of this equation, where delta sub C sub S corresponds to the nominal sensor capacitance minus the capacitance C sub B, which model the effect of analyte in the biosensor. The operational amplifier used in this work is a complementary transconductance amplifier with a source follower as an output stage. The complementary differential pairs provides ensure rate-to-rail operation, and the low voltage current mirrors provides a high output impedance, which allows to achieve a gain greater than 60 dB in a single stage. This op-amp is a single-ended version of reference 2, which is robust against process and temperature variations. Table 2 summarizes op-amp parameters, which the gain and DC power consumption stands out. Also, the phase margin and unity gain frequency are important parameters over the transient response of the integrator. The control circuit generates the non-overlapping phases from a master clock signal, enables the up-down counter, and generates the calibration and measurement phases. With the first pulse of the start signal, the calibration stage begins and the counter works downward until the count comparator detects a 2 to n-1 value. The D signal stops the calibration phase as the system enters an idle phase until the logic control detects a second start signal pulse. Then measurement phase starts and the counter works upward until a zero comparator detects an integrated output voltage of 0. The counter is enabled by next door logic with measurement and calibration phases as inputs. The calibration phase is generated from the first pulse of the start signal, the measurement phase, and the D signal. The measurement phase is activated with the second pulse of the start signal, and when the calibration phase is deactivated. The calibration and measurement stages are carried out at T-sat-in and T-sat-in times, respectively. And given that during calibration and measurement phases, the only difference in the system is the biosensor capacitance variation, the relationship between T-sat-in and T-sat-in are given by this equation, where C sub SA corresponds to the capacitance with analyte and can be taken as that is the relationship. That is the sensor, the nominal sensor capacitance multiplied by an 1 over X factor. The system output is generated from the subtraction of the calibration con value P and from the measurement con value Q, which is performed by using the counter in ascending mode for the calibration phase and in ascending mode in the measurement phase. Since the output digital word is generated from the difference between the calibration and measurement phases times, the system performs an indirect time to digital conversion. Okay, the system was simulated in HSpice with a 180 nanometer CMOS technology. The nominal biosensor of the capacitance was 100 picofarads. At the maximum sensor capacitance variation was 50 picofarads. The integration capacitance, the resolution of the counter, and the voltage reference remains as system design variables. The selected integrator gain was 10 to improve the relative precision between the integration capacitance and sensor capacitance. So the integration capacitance is 10 picofarads. The resolution of counter was 8 due to the trade-off between the system conversion time and system resolution. And since the maximum integrator output voltage must be less than the supply voltage, for a maximum integrator voltage of 1.2 volts, integrator state voltage of 9.4 millivolts is obtained. And then the reference voltage is 0.94 millivolts, putting all these parameters in this equation. Okay. In figure 11, the voltage variation and the integrator output is shown for variation of 10% in the biosensor capacitance. And as can be seen, the variation of the sensor capacitance affects only the maximum value of the integrator voltage in the calibration phase. But given that the difference between the calibration and measurement phases is taken for the capacitance to digital conversion, the system is immune to biosensor variations due to manufacturing process. The value of being the maximum integrator voltage output and the resolution of the counter can be chosen to compensate larger biosensor capacitance variations and improve the resolution of the system. The timing diagram is shown in figure 12. Here it shows how the start signal generates the calibration and measurement phases by taking a sensor without analyte and a sensor without the maximum variation of capacitance, which corresponds to 50 picofarads. With the first start signal pulse, the system is calibrated in both cases. And with the second pulse, the capacitance variation measurement is performed in these two. In figure 13, the system digital output as a function of the factor of change is shown. In the experiment, a variation of 10% in the biosensor was considered, and the results shows a high linearity and robustness against variations in sensor capacitance due to manufacturing process. Finally, table 3 shows a comparison with other similar works. This one has a lower power consumption, doesn't use a reference capacitor, and it's self-calibrated. Okay, in conclusion, a self-calibrated Redux system for a capacitive biosensor was presented. It uses an operational amplifier that compensates process and temperature variations, and was proposed, this op-amp. And the system does not require a reference capacitor for calibration. It is robust against sensor and manufacturing process variations. It has a lower power consumption compared with other similar words, and the system performs an indirect time to digital conversions with a change in capacitance insertion due to the amount of analyte is converted to a digital word through an up-down counter. Thank you so much. And if you have any questions, feel free to ask.
Thank you for your presentation. We have 3 minutes for any questions from the audience. Okay.
And that's all.
Yeah.
Okay.
So no questions. Okay.
Okay. Thank you so much.
Thank you. So I thank all our authors for their excellent presentation in this session, and all our participants for being a part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 working days, and all the papers have already been forwarded to this paper. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT as and when intimated. And I would also like to thank Dr. Libero for his questions and this presentation. Thank you all for your valuable presence. And I kindly request all to turn on their cameras for a quick snapshot of the virtual conference, please. Okay. Thank you.
Hi, anyone, any questions for this presentation? And thank you very much. And I apologize on behalf of the chair that he was not able to present in this session due to some technical glitches in his system. And over to Basil to close this session with the closing remarks.
I did close already, and we took the snapshot right now. Just a minute. I'll take it again. Okay, thank you. Okay, thank you. I just closed the closing marks, Ahmed.
Okay, perfect.
Yeah. And I took this snapshot again. So,
no worries.
Yeah.
It's all good. So everyone have a safe time. The things are getting different at different places due to the pandemic. So stay safe and stay precautive, right?
Yes. Take care.
Thank you very much. And I think we will have another 40 minutes break because it's already. So how much time, Basil, for the next session?
Next session will start at 1:55 GMT.
So how much time is left?
It's left around 17 minutes.
So I think another 15 minutes we'll be gathering back here for the next session, and look forward to see you all. The chat window is still open. We are not closing this session. So just try to interact with each other so that you can have some fruitful discussions and collaborations. Thank you.
Thank you.
Hello? Can anybody hear me? Hello? Hello?
Yes, Dr. Santos. Yes, we do hear you. We will start after 5 minutes as scheduled.
Good. So what am I going to tell you is, in place of me, Professor Harun Lon, my faculty is going to join because I've got the keynote talk in the other conference at the same time. That makes sense?
Okay. It's okay. It's okay.
Okay, so HARONLONE. Harun Lon is going to join from my department. Make sense?
Oh, yes. Thank you.
Good. Thanks. Thank you. Just that. Thank you. I'll see you. Good luck.
See you. You too. Thank you.
Hi, everyone. Good afternoon. And we'll be starting the session in next 2 minutes. So just be patient for next 2 more minutes. Thank you. Hi everyone, and welcome this session number 2E. I think this is 2F. Sorry, 2F. So Basil, can we start the session?
Yes, we can start.
Perfect.
Okay, good afternoon, everyone. It is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT and Global Knowledge Research Foundation. As every one of us is passing through unseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we will all together pass this soon. Further, with immense happiness, I would like to share that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. And the papers will publish in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of the knowledgeful and interactive sessions. I would like to welcome you to the technical session number 6 and further introduce you all to the chair for this session, Dr. Harun Loan. I'm sorry, but Professor Casey Santos cannot make it today. And few words, Dr. Harun.
Hi, good afternoon, everyone. My name is Harun Loan, and I'm an assistant professor at the University of South Dakota. I welcome all the presenters in this conference, and I hope everyone will be able to share the knowledge and will get the correct feedback. Thank you.
Thank you, Dr. Harun. First, we will start by the first presenter. There is a presenter called Pidita Amahan. He's going to, she is going to present first because she has some technical issues, I guess, as requested. She is going to present vetting the influence of ISO 9126 software characteristics in the development of mobile applications. The floor is yours. You have 12 minutes to present.
Thank you so much. Are you able to hear me?
Yes, we are able to hear you, yes.
Can you be able to show to view my presentation? Can I start now?
No. Your folder.
Did I successfully share my screen?
Yes.
Okay, thank you. So good morning, everyone, and it's already 9:55 in the Philippines. I would like to present my paper entitled with Vetting the Influence of ISO 9126 Software Characteristics in the Development of Mobile Applications. I am Ms. Pilita A. Amahan from Occidental Mindoro State College, Philippines. The infrastructures of mobile applications.
Sorry to interrupt you, but yes, yeah, we can see a folder, but there's no presentation.
So I would like to.
Yes, it is visible right now.
Okay, so I have to continue this one. So the infrastructures of mobile applications have become dependent on how it is being built by the software developers. And with that dependence given, it became the gateway to attract exploitation, causing malicious intents to cyberspace. And that exploitation could also lead for some vulnerabilities of software, caused by inconformities that may lead conflict with the specifications of softwares in the execution of security policy. Though the development of software applications is being guided by the system's development lifecycle, or the SDLC, that includes the phases of analysis, design, coding, testing, installing, and maintaining the system, and with the proper guidance of ISO 9126 metrics to test the capability of the system, it still contributes some issues regarding data, such as crashing, freezing of data, data conflicts, data synchronizations, that leads the proponent to vet the functionality issues that lies during the development and testing phase. And also, according to Ogata et al., that there is a need to vet offline mobile applications as they are very seldom to visit. So generally, this would like to assess the influence of mobile applications against the metrics of ISO 9126. Specifically, this study would like to identify the degree of influence of mobile applications against the ISO metrics. Also, for me to determine the least sub-characteristics of software product from the evaluation of the study. And lastly, to propose a framework that will benefits the trade-off analysis in the enhancement of weak sub-characteristics of ISO 9126 that will be found in the study. So for the methodology of the study, random sampling techniques has been utilized among the 15 capstone manuscripts that were observed during the 3 consecutive years of 2016 to 2019, having the total of 45 manuscripts that were being observed. So the table shows the core component of ISO 9126, and this element has been observed and has been recorded the general weighted mean that's shown in the against the row of the table. So the characteristics of ISO 9126 is composed of the following: contents, organization and design, mechanics, comprehensibility, functionality, and maintainability. And to put this one into a graphical formation, this illustrates the influence of mobile applications against the metrics of ISO 9126. And it shows that the maintainability having the general weighted mean of 4.58 leads to the top, and it follows with the contents of the system having the general mean of 4.55. The next is the organization and design for 4.54, the mechanics of the study of the system having 4.49 general weighted mean, followed by comprehensibility for about 4.48. And with this graph, it illustrates that the functionality of the system were observed as the least among the 6 components of isometrics. Although 4.38 is still in the passing level of Likert scale, but this leads to an alarming one, especially to the developers of the mobile applications. So for me to further investigate the reason behind the functionality of the system becomes the weakest component against the characteristics of ISO, I had investigated what might be the cause of that case. So I had investigated the subcomponents of the functionality that is composed of ease of operation, provision for comfort and convenience, and user friendliness for the 3 consecutive years. And to put this one into a graphical formation, it is found out that the ease of operation uh, drops into the lowest general weighted mean that might cause the functionality into the lowest general weighted mean, followed by its provision for comfort and convenience, and it follows with the user friendliness and learnability. So I had conducted a related literature also for the factors affecting the usability of software project, and this might be the reason. So there might be a reason for the adoption factors for the usage of automation tools. There